Welcome to solverfy.
All right, in question 45, we're looking at ethanol. Ethanol, which is C2H5OH. And we're looking at a heating curve of it. They don't draw the heating curve out, but personally, I think it's the easiest way to kind of get all your information written down. So I would draw out your heating curve, where here it's a solid, here it's a liquid, and here it's a gas. And they tell you that you have 42.0 grams of your ethanol. And it tells you that the melting point, so right here, is at negative 114 degrees Celsius. And your boiling point is at 78 degrees Celsius. That's right here. Your delta H of fusion, which would go right here, is equal to 5.02. It's kilojoules per mole. Try to push it in there. And the enthalpy of vaporization, which is going to go up here, is 38.56 kilojoules per mole. The specific heat of the solid, which is going to be right here, so our C for our solid is equal to 0.97, and that's joules per gram Kelvin. And our specific heat of our liquid is equal to 2.3 joules per gram Kelvin. So I would organize all your data like this. It helps you to see what steps are needed for this problem. So in question A, we're converting, they want to know how much heat it takes to convert for the 42 grams of ethanol that's starting at 35 degrees Celsius. So at 35 degrees Celsius, it would be in this area, it would be a liquid. And we're going to take it to a gas, a vapor, at 78 degrees Celsius. But we want it to be in the vapor phase, in the gas phase. All right, I'm going to go ahead and go to a clean sheet here just so we have a little more space to solve this problem. So let's talk again about the steps we're going to take. We are taking the liquid from 35 degrees Celsius up to first the boiling point. So we're going to first heat it up to 78 degrees Celsius. And then in step 2 is where we're going to convert it from a liquid to a gas because they want it in the vapor stage. So step 1 is that heating up. This is where the heating curve is like at a diagonal. And that's where you're going to use the equation Q equals mc delta T, where the mass is 42 degrees Celsius, 42 grams. The C for that is we're at the liquid, so this is 2.3 joules per gram Kelvin. And then the change in temperature. So I'm going to go ahead and do the change in temperature in Celsius, even though this is per Kelvin, because since you're doing a change, the change in temperature in Kelvin will be equal to the change in temperature in Celsius, since the size of a degree in Kelvin is the same as the size in a degree in Celsius. If it was absolute temperature, you couldn't do this. But since it's a change in temperature, you can. So this will be 78 degrees Celsius minus 35 degrees Celsius. You plug all this into your calculator, you get 4,153.8 joules. I'm going to go ahead and divide that by 1,000 to convert to kilojoules. So that will be 4.1538 kilojoules for that step. In the second step, we are going to be heating it. We're going to be adding heat in order for the phase change. So this is where we are going from the liquid to the gas. We're vaporizing. And so we need to use our delta H of vaporization. And our delta H of vaporization is in kilojoules per mole. So we're going to need to take that and multiply it, the amount of heat times the moles. So I need to convert my substance to moles. So I have 42.0 grams of my ethanol, that's C2H5OH, and I need to convert it to moles. So 1 mole of my substance, and the molar mass is 46 grams. So I get 1 mole is equal to 0.913, or sorry, 42 grams is equal to 0.913 moles of my substance. So the amount of heat that I need to add here is equal to the heat of vaporization, which was the 38.56 kilojoules per mole, times the number of moles, so times the 0.913 moles. And that is going to be equal to 35.2 kilojoules. So the total amount of heat to make this process occur is going to be the sum of those two, and it's rounded to 3 sig figs, is going to be equal to 39.3 kilojoules. So that's part A. In part B, we are taking, again, we still have the same mass, we still have the 42 grams of our substance, but in this case we're taking it from negative 155 degrees Celsius up again to 78 degrees, but as a, again as a gas, as a vapor. So let's talk about the steps we're going to need to do. So negative 155 degrees Celsius is below the melting point. So the first thing we're going to have to do is warm it up, is increase the temperature up to the melting point of negative 114 degrees Celsius. In step 2, we will melt it. We'll convert it from a solid to a liquid. In step 3, we're going to warm it from the melting point, the negative 114 degrees Celsius, up to the boiling point of 78 degrees Celsius. And in step 4, we're going to vaporize it and change it from a liquid to a gas. So let's come over here. I'm going to do step 1. So in step 1, we're heating our substance up. So again, that's a diagonal. That's a Q equation. So Q equals mc delta T, where the mass again is 42.0 grams. The C at this step, this is a solid, so the C is 0.97 joules per gram Kelvin, times the change in temperature, and I'm ending at negative, so change in temperature should equal T final minus T initial. So that's negative 114 degrees Celsius minus the negative 155 degrees Celsius. And so I get here 1,670 joules divided by 1,000 will give me 1.67 kilojoules. So that's the energy for the heat added for step 1. In step 2, we are melting. So we're going to, our heat here is going to be equal to our delta H of fusion times the moles, since this is per mole. So that will be, the delta H of fusion given was 5.02 kilojoules per mole, times, we already calculated the moles as 0.913. So that's going to be equal to 4.58 kilojoules for that step. In step 3, this is where we're heating it from negative 114 to 78, the boiling point. So this is a Q equation again, Q equals mc delta T. The mass is 42 degrees, or I keep saying that, 42 grams. The C for this portion is 2.3, because this is the C for the liquid, 2.3 joules per gram Kelvin. And the change in temperature is, the final temperature is 78 degrees Celsius minus the initial temperature of negative 114 degrees Celsius. And for that, I get 18,547 joules. Dividing by 1,000, that is 18.55. I'm not going to worry about rounding in the middle of this problem. Kilojoules. Finally, step 4, I'm vaporizing it, which I did in the last problem, but I'll go ahead and write it out again, and I did that in part A. And so this is going to be equal to the heat of vaporization times the moles. So that's going to be equal to the 38.56 kilojoules per mole times your number of moles, which is 0.913. And that is going to be equal to 35.21 kilojoules. So I'm going to add all 4 of these steps together, round to 3 sig figs, and I get a total equal to 60.0 kilojoules.